Okay, part 3, I'm going to do number 11. It's similar to one we did in class. It might even be almost identical. We're asked to find the area of this trapezoid, but first we need to find the other base and the height before we can find the area. So looking at this trapezoid, I can see that if I drop a height down here at a 90-degree angle, that I have cut off a triangle on this end that is a 30, 60, 90. So given the hypotenuse of a 30, 60, 90, I can find the short side, and the short side of this little triangle here will be 4, half of the hypotenuse. And then the height of this 30, 60, 90 degree triangle will be 4 rad 3. So I've already found the height very quickly just by dropping a height and noticing that this is a 30, 60, 90. Now I still need to find this base. If I drop another height on this side from the corner straight down at a 90-degree angle, this is a 30, 60, 90 degree triangle. This is 8 and this is 4. This is half of the hypotenuse. If this segment is 4 and this segment is 4, this segment here is 8. This is a rectangle that we've created here with 90-degree angles. This is 8. And now I have the other base. 4 plus 4 is 8, plus 8 is 16. So this whole base is 16. The area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. That's equal to 1/2 of 8 plus 16 times 4 rad 3. Let's simplify this. 1/2 of 24 times 4 rad 3. 1/2 of 24 is 12 times 4 rad 3, and that's 48 rad 3. And that's the area of this trapezoid. Not as hard as it actually looks. Now number 12, I'm going to give you a hint and then I'll come back to it. So number 12 is a regular octagon. The way to find the area of this regular octagon, knowing what we know right now, is we can divide this top portion into a trapezoid and this bottom part into a trapezoid, and this middle will be a rectangle. So if we can find the area of this trapezoid and add them together, this area will be the same as this. So we just find the area of this trapezoid and double it, and add it to the area of the rectangle in the middle. Well, we can drop a height down for this top trapezoid, and we can draw one over here too. We know that this is 8 and this is 8 because this is a regular octagon. These are all 8. But to find the area of this trapezoid, we need to find the length of this bottom base and the height. The key to finding the area of this trapezoid is to recognize that by dividing this segment down here like this, we have made a 45, 90 degree triangle here. This is a 45, 90. This is a 45, 90. There are a couple different ways we could prove that. One of them is to recognize that since this is a regular octagon, all the angles are congruent. So this whole angle is congruent to this whole angle. If this whole angle is congruent to this whole angle, if I subtract 90 from this, I will get an angle here that is congruent to as if I subtract 90 from this whole angle. Two angles that are complementary. Let's see, how would I say that? Two angles that add up to the same number, and one of them is 90, they're congruent. Another way to do it would be to say that this whole angle and this whole angle, these all angles are the same. We could find out the measure of that one angle in an octagon. the measure of that one angle is 135. So each angle in a regular octagon is 135. You would have to do that by finding the interior angle sum and dividing it by 8. And it equals 135. I can leave that for you to figure out. If that whole angle is 135, then if I take 90 from it, that angle is 45. So there's, a number of ways to show that this is a 45, 45, 90. If this hypotenuse of this 45, 45, 90 is 8, then these little pieces are going to be 8 divided by rad 2. If we simplify that, we get 8 rad 2 over 2. I'm just multiplying both top and bottom by rad 2. And we can simplify that further to get 4 rad 2. So what happens is we end up with a trapezoid with a base of 8, and then this piece right here is 8. This is 8, this is 8. And this height is 4 rad 2, and this segment is 4 rad 2. And the same goes on this side of the trapezoid. If this is 8, then this is 8 divided by rad 2, and so it's 4 rad 2. And we can find the area of this trapezoid. The area of the trapezoid equals 1/2 of base 1 plus base 2 times the height. That's 1/2 of 8 plus 8 plus, now this is the second base, 8 plus 8 rad 2. I just added up that plus that to get 8 rad 2 plus 8. I guess I'm going to do most of this problem. Oops. Okay, so the area is equal to 1/2 of, simplifying this, is 16 plus 8 rad 2. That's equal to 1/2 of 16 is 8, and 1/2 of, I'm distributing the 1/2. 1/2 of 16 is 8, and 1/2 of 8 rad 2 is 4 rad 2. Now that has to be multiplied by the height. And the height is 4 rad 2. So this whole number here has to be multiplied by 4 rad 2. Four rad 2 times 8 is 32 rad 2. And 4 rad 2 times 4 rad 2 is 16 times 2, which is 32. Okay, there's other ways you could have multiplied that out. You could have multiplied 1/2 times 4 rad 2 first to get 2 rad 2, and then distributed 2 rad 2 to each of those numbers. There's multiple ways to simplify that. But this is what you will get. And that is the area of the trapezoid on the top. That means that's the area of the trapezoid on the bottom, so we can just double that. So both trapezoids together will be 64 rad 2 plus 64. I'm just multiplying that whole thing by 2 to get the total area of both the trapezoids. Now the area of the rectangle is going to be equal to 8 times, it's the base times the height, so it's going to be this base, which we determined to be 4 rad 2 plus 8 plus 4 rad 2, and we're going to multiply that by 8. So the rectangle is, this is 8, and this is 4 rad 2 plus 8 plus 4 rad 2. That's 8 rad 2 plus 8. I'm going to multiply this times the height. Sorry about that. So 8 rad 2 plus 8 times 8 equals 64 rad 2 plus 64. And that is the area of the rectangle. So both the trapezoids equal this, and the area of the rectangle equals this. Let's add these two together. 64 rad 2 plus 64 plus 64 rad 2 plus 64. I'll combine those. That's 128. And I'll combine these. That's 128 rad 2. And that is the area of that regular octagon. A very challenging problem, but very doable if you do it piece by piece and very carefully. Okay, I'm going to move on to number 13 through 18. And these are review from previous days. The area of a parallelogram is equal to base times height. For number 13, we're told that the area is 20, the base is 50, and we're asked to find the other height. The height. Area is 20 equals 50 times the height. I'll just divide both sides by 50, so 20 over 50 equals the height. I can simplify this fraction, and I get 2/5. Now, if you write 0.4 for the height, that's okay. Most of the time, if you're given, it's better to leave it in fractional form for the most part, because we're trying to avoid any kind of calculator for a lot of these. But this is not wrong. Oh, that should be it's 0.4. Fractions might be a better choice for some of these. All right, number 14. Here is a square, and we're told the area is 20. Well, the area of a square is s squared, right? It's the base times the height. But this is side, and this is a side that are congruent. All the sides are congruent. So area of a square is s squared. So if the area is 20, if I want to find just a side, I will take the square root of it. S times s is 20, so I will just take the square root of 20, and I can simplify that to 2 rad 5, and that's the measure of the side. The perimeter of a square is going to be that plus that plus that plus that, right? Each side plus each side, or just 4 times the side. So 4 times 2 is 8, and so the perimeter is 8 rad 5. 2 rad 5 plus itself 4 times. Number 15. Here are some angles. Let's see, here's an angle that's been created by 2 chords. It's on the inside of the circle. When you have an angle created on the inside of a circle, that angle equals 1/2 of the sum of the measure of the arcs that it creates. So 40 equals 1/2 of x plus 52. To solve this, I'll multiply both sides by 2. I get 80 equals 52 plus x. Subtracting 52 from both sides gives 28 equals x. Just to double check, if I take 28 and add it to 52, I get 80. If I take half of that, I get 40, and that's correct. Number 16 is the measure of segments inside of a circle created by 2 chords. And the theorem states that this segment times this segment, 3 times x, is going to be equal to this segment times this segment, 5 times 4. So 3x equals 20. Dividing both sides by 3 gives x equals 20 over 3. Now, if we put that in the calculator, we might not get a good result. We don't want to use the calculator if we don't have to. Just leave it as a fraction. Number 17. 17 tells us about a length of an arc. So the length of an arc means we're going to either use the equation or the proportion for the length of an arc. In this case, I'm going to use the proportion. L is to 2 pi r as x is to 360. This is the proportion that puts the segment of the circle over the entire circumference equal to the measure of the central angle that creates it over 360. So what are we given? We're given 150 over 360. This degrees goes here. And the length of the arc goes here over the circumference. And we're going to simplify a little bit before we cross multiply to solve for the radius. So let's cross multiply after we simplify. Let's get rid of the pi's. Those can cancel. We can cancel those zeros, divide both of those by 10. So we get 25 over 2r equals 15 over 36. I'm going to go ahead and cross multiply now and solve for r. So 25 times 36 equals 15 times 2r. That's 30r on the right, and now is a good time to get a calculator, but I'll go ahead and just do it the long way. 25 times 36, that's 315, 51700. I get 900 for the left side. 900 equals 30r. Divide both sides by 30. R equals 30. And there's the radius. Using the proportion to find the arc length. To use the arc length. Last one, 18. 18 is a triangle with sides 5, 6, and 8 acute, right, or obtuse? Well, using the Pythagorean theorems and their corollaries, if I square 5, add it to 6 squared, and compare it to 8 squared, I'll be able to determine if it's acute or right or obtuse. This is 25 plus 36. This is 64. Is this less than, greater than, or equal to? Is this side less than or greater than or equal to 64? Well, this is 61. 61 is less than 64. So that means that the longest side is larger than the two smaller sides squared. So the larger side squared is greater than the two smaller sides squared added up together. This is obtuse. So number 18, the triangle is obtuse. That is a lengthy assignment, and you guys, I will see you tomorrow and we can go over any questions you might have about it. Good luck and have a nice evening.